Hi, I'm Andrew, and I'm doing FRQ 2013 number 6. So, number 6 says, consider the differential equation dy over dx equals e to the power of y times 3x squared minus 6x. Let y equal f of x be the particular solution to the differential equation that passes through 1, 0. 6a says, write an equation for a line tangent to the graph of f at the point 1, 0. Use the tangent line to approximate f of 1.2. Now 6b says, find y equals f of x, the particular solution to a differential equation that passes through 1, 0. Okay, now let's start with 6a. So, for the equation of a tangent line, it is y minus y of 1 equals m times x minus x of 1. Now, y of 1 is equal to 0 and x of 1 is equal to 1. And then dy over dx equals m, and m represents the slope of the tangent line. So that means because dy over dx equals m, then m equals e to the y times 3x squared minus 6x. So, knowing that m equals e to the y of 3x squared minus 6x, we could then plug in y and x to get e to the 0 times 3 times 1 squared minus 6 times 1. And you get 1 times 3 minus 6, and then m is equal to negative 3. Okay, then we must plug everything back into the equation of the tangent line, which is y minus y to the 1 equals m times x minus x to the 1. So then we plug everything in, and we get y minus 0 equals negative 3 times x minus 1. Then we distribute everything out, and we get y equals negative 3x plus 3. Okay, so with the equation of the tangent line, y equals negative 3x plus 3, we want to find what y equals when x equals 1.2. So we plug in 1.2 for x, and we get y equals negative 3 times 1.2 plus 3. And we get y equals negative 3.6 plus 3. Then that means y equals negative 0.6. And that means f of 1.2 equals negative 0.6. Okay, so let's do 6b now, which is find y equals f of x, the particular solution to the differential equation that passes through 1, 0. Now, the differential equation is dy over dx equals e to the y times 3x squared minus 6x. So what we want to do first is split up the variables. So we divide both sides by e to the y, and we get d to the y divided by e to the y. Then we times both sides by d to the x, and we get 3x squared minus 6x times d to the x. And because e to the y is in the denominator, we could put it as e to the negative y, because it's the same as adding e to the negative 1. And then we get e to the negative y times d to the y equals 3x squared minus 6x times d to the x. Then we take the antiderivative of both sides, and we get negative e to the negative y equals x cubed minus 3x squared plus c. Make sure not to forget the plus c. So with our equation now, negative e to the negative y equals x cubed minus 3x squared plus c, we must get rid of the negative on the left side, so we have to put it on the right side by dividing everything on the right side by negative 1, and we get e to the negative y equals negative x cubed plus 3x squared plus c. And c doesn't get affected by it because c is just a constant that will be able to change later on, so it doesn't really matter in this situation. So now we have to take the ln of both sides to get rid of e, and we get ln e to negative y equals ln negative x cubed plus 3x squared plus c. And for ln e to the negative y, it simplifies out to be negative y. And then negative y is equal to ln negative x cubed plus 3x squared plus c. Then we divide both sides by negative 1, and we get y equals negative ln negative x cubed plus 3x squared plus c. So now what we must do now, because we have a constant in our equation, we have to solve for the constant, which is c, which is in y equals negative ln negative x cubed plus 3x squared plus c. So now we plug in 1, 0 because the differential equation passes through 1, 0. So we plug in 0 for y and x for 1, and we get 0 equals negative ln times negative 1 cubed plus 3 times 1 squared plus c. So then, because we know ln of 1 is equal to 0, we have to set the inside of ln equal to 1. So we have to do negative 1 plus 3 plus c equals 1. And then we add the 1 to the other side and subtract by 3. And we get c is equal to negative 1. So then for our final equation, for the particular solution, we get y equals negative ln negative x cubed plus 3x squared minus 1. And that's how we get the differential equation for the particular solution that passes through 1, 0. Okay, so this is the end for problem number 6, FRQ 2013. Now there are many other ways to solve this problem, but I use this certain method to solve number 6. And this is the end by Andrew. And yeah.